Record. What did I just hit record to? Hang on. Oh, no, never mind.
I
Okay.
think you're recording now, yeah. I think you're good.
Yeah, I'm recording. Yeah, I just wanted to make sure I'm recording to the cloud and not the computer. I don't want to fill up the memories all alone. Memories all alone in the moonlight. Cats, anybody?
I haven't heard that in like
Uh-oh. All these ahead of time, so we will be solving these together. So what are some good, so right, we're asked to write a function, just for the recap of the YouTube, right, that takes in a string that returns whether or not the string is a palindrome. So a palindrome is any word that is spelled the same forwards and backwards. Goal, try and solve this problem in multiple ways. So what's one of the first things we should do?
Put the string to lowercase or uppercase.
Write down our rules.
So lay down rules, uppercase, lowercase. Yeah, so we're all kind of on the same page, right? So we should be asking, like, are we concerned with string casing, right? So that kind of talks about, this is like kind of a clarifying question. So for our problem, let's say we don't have to worry about that. What else might we think about and ask?
like the type of output or like maybe the input, like are there gonna be numbers, just like stuff like that, like what our input look like.
Okay. Will there be numbers or punctuation, right, to worry about? So Marvin said something also about input, right? Let's like get some example inputs and outputs, right? I purposely didn't write that in today because I wanted us to think of those. So let's come up with some inputs. So what's a good input for us to check?
Race car.
Race car. Oh,
Okay.
damn, beat me to it, Henry.
Race car. Oh, wait, sorry, guys.
So this should give us back output should be true. What's another good one?
ABBA.
Dad.
I'm going to go with ABBA. And the reason I'm going to go with ABBA,
They're a great band.
Sure, they're a great band, but we already have an odd length palindrome. So it's important, like, so if it works for a race car, it probably works for dad because they're both odd, but we want to make sure that it also is going to work for something that's of even length. So this is like the different type of palindrome. So that's why I'm including ABBA instead of dad. Output is true.
Do a man plan a canal, Panama?
A man, a plan, a canal, Panama. All right. So this is supposed to be true, apparently. And then, yeah, so are we worried about spaces, right? That's something we should ask about. Will there be spaces? We should come up with some false things that should return false, right? So like A, B, like false. What about if I give this? Is this a palindrome?
No.
It could be. You could reverse nothing to nothing.
Right, so this is definitely something that is up to your interviewer, right? Is an empty string a palindrome? Now, maybe your interviewer says it is, maybe they don't, right? But it's worth a discussion. So we'll just put a question mark for now, because I don't know what we want to do. Okay, so these are some good questions. So let's start brainstorming some approaches. So who could tell me one approach that they took?
For me, I just did like a simple like reverse thing. So I did a string dot split, and I changed it with a string dot reverse and a join. And then I just I set that to a new variable, and then I just did a conditional that checked to see if that input string equaled that new variable. If it did, it will return true. If not, it will return false.
Okay, let's do it. Okay, let's try it. Let's build that out. I think that one's pretty straightforward, right? So we'll say const is palindrome 1. This will take in our string, and this, right, we can just say string equal to string dot split, whoops, dot reverse dot join. Okay. So, right, this is one way of writing this. Let's just make sure that this works. So let's say console.log, and we'll have is palindrome 1. We'll invoke it, and we have 1, 2, 3, 4. Okay, and we'll just add our samples. Try ABBA. I've been cheated by you, and I think you know when. Okay, maybe I did too many. We'll also we'll just throw this in, see if they handle things differently, any of these. Okay, so we're expecting 3 trues, a false, and, well, we haven't really decided what we want there. So we'll say node DSA. What do you mean, am I good, Corey? From the songs? I'm great, Henry. Am I acting really weird? I feel fine. I had a good sleep. Okay, true, 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 false, and true. So, okay, so this is working. This is a valid solution. What's the time complexity of this?
Linear.
Yep, right, this is linear. I think linear is as fast as we can actually go for this problem, right? Because no matter what we do it, we're still going to be looping. If we wanted to get like really specific, what would be the time complexity? Like, if we didn't want to, like, yes, no matter like how many n is this? Even though it will eventually, just as we approach infinity, become n, how many n is this?
Wouldn't that be like dependent on the length, right? Or am I?
No, so Siham wrote 3, right? Because split is iterative, so we have to iterate through the whole string here, and then we're reversing, which is another iteration, and then we're joining, which is another iteration. So this is 3n, even though that still, becomes n. It's still n, but it's 3n. So, like, although the time complexity is linear, we can still do better than this, because here we're still doing 3 loops when we could, and we'll write more solutions where we'll move towards 1n, right? So, which would be really a third the speed of this one, even though they're still the same time complexity. I know that's a little weird to think about it that way. How about memory or space complexity?
Linear.
Linear?
Yeah, right? This is also linear. Can somebody tell me why this is linear?
Because the starting str is equal to a new string that you're creating.
Yep.
So every time you have a string input, that's gonna grow by whatever new string you're creating.
Yep. Right, because this split turns into an array, and that's an array that wasn't in memory before. Then we're also joining and turning that into a string. It might technically be 2n, but right, it ends up becoming n. So we'll say space. We'll say space is n. So we can do better than that too, right? Which will be the goal. So if we know we can't technically get faster than n, maybe we can use constant space or something instead of n space. So although the solution is valid, it may not be our ideal solution. So let's continue working and seeing if we can figure out a second solution. So we'll say isPalindrome 2 takes in a string. So can anybody tell me another approach that they had?
You can do a for loop.
Iterating. Yeah, for loop.
Okay. Can somebody kind of walk me through that so I know what we're thinking?
Okay. First, I just changed the string to be lowercase. So I said string equals string that's lowercase.
Okay. Well, okay, so we'll do that. Let's pretend. Let's just pretend. Let's keep it the same. Let's pretend it's already lowercase for this
Okay.
one.
So for let I equal 0, I is less than string dot length I plus plus.
Okay.
If string at I is not equal to string at string dot length -1 minus I.
Yep.
Return false. Otherwise, at the end, return true.
Okay. I like this. This is cool. Let's see if this works. Okay. So we're expecting similar results. Okay. So we get our true, 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 and our false. So let's talk about this. Time complexity. What are we at?
Linear.
Linear.
Yeah. So still n. We could say we'll say I'm just going to say 1n to stay consistent to like how we were writing it before. What's our space?
1n as well, or
Do we have to add more space for the size
No.
string that we're creating?
no, we don't, because this is going to be for the it's the same length of the string that we're creating, right? So we don't.
Right. So there's no addition. Or Doug, you want to answer? Doug, will you answer this? I heard you say no too.
Yeah, we're just using that same string, so we're not creating additional space.
Okay.
Perfect. Right. So this would make this constant space because we don't have to add any space. So this is already a better answer than palindrome 1. Is anybody? So let's walk through this a little bit and see how this is working, because this one's a little bit more complicated than the one above. Okay, so let's do it with ABBA because it's short. So let's say we have the string. This is our input, is ABBA. We'll start with our I, which is going to start at 0. And we're going to iterate through this. So we're going to see string at I. So string at I, we'll just like do it like string at I, right? This is currently A. And then we'll also look at this line, because this line is kind of interesting. And so when I is 0, sorry, computer fell asleep. Okay, so when I is 0, we say string dot length, which is our length is 4, right? -1, so that gives us 3. -0 stays at 3. And so 0, 1, 2, 3, that gives us our A. So this is also A. Okay, so we check, they are the same. So we're not going to go into this if statement. Our I will get incremented by 1, and we'll start our next iteration. So now we'll say string at I, so string at 1, which gives us a B. And we look at string at length, so 4 minus 1 is 3, minus 1, because that's our I, is 2. So we say 0, 1, 2, and we have our B there. And we've done our comparison. And now we don't go into our if statement, and so we continue. I gets incremented by 1, we go to 2. String at I, so I at 2 is this B now. So it's still B. And we look at string at length minus 1. So 4 minus 2, 1 is 3, minus 2 is 1. So now we're looking at this B. We don't go in our if statement. We continue, and I gets incremented to 3. String at I is, yes.
Can you make it, I guess, would it be more efficient to, in line 402, in the middle, well, I is there, in line 402 where it says string not left divided by 2?
So Henry's saying, so this is good. This is what I was hoping somebody would say, right? Henry, I'm going to bounce right back to that in a second. I'm just going to finish doing this iteration, right? So I gets incremented to 3 now, and we look, and now we're at this A, and we see string.length minus, so 4 minus 1 is 1, minus I, 4 minus 1 is 3, minus I is 0. So now we're at this A, not the same, doesn't go in, I gets incremented to 4. Now we don't pass our conditional anymore, and we go ahead out of the for loop and return true. But what Henry's saying is, we already checked that B when I was 3, and we already checked this A when I was 4. So we're wasting time. So why not instead say math.floor string.length divide by 2? Will this still work? Well, I don't know. Let's see. Yes, right? So this still works, but now this is really only like 1/2 of n, essentially, which is still n. Wow, that's supposed to be a 2, sorry. Which is still n, but it's faster than the other one without this, because it's doing half the number of iterations.
Corey, what did you just do there? I don't get it. I don't get what's happening with the math floor and then dividing it the length by 2.
So before we checked A and A, B and B, then this B with this B, and then this A with this A.
Yeah.
But those last 2 operations, we've already checked those characters. The first A was this A, right, with this A. But the last iteration was this A with this A. That's already been done. So checking it again is redundant. So by dividing our length in half, we are only checking the first half of the string with the last half of the string, instead of checking the first half with the last half and then the last half also with the first half.
Okay, that makes sense. Okay. Okay.
Cool.
Corey, I have a quick question.
Yeah.
So I probably like answered it myself, but is line 43 constant? Or because we're working backwards and iterating backwards, are we like, we're not looping through it, but
What do you mean by
are we?
43? Where are we looking?
Like the if statement.
Oh, 403. Sorry.
Yeah, 403, sorry.
Yeah, this is still constant because keying into an array is a constant speed operation, and doing a comparison is constant, essentially. I mean, you could get into some technicalities there where, like, if I'm comparing two strings, like they have to be iterating through the strings to check, that's kind of under the hood, and we often just give that as a constant. So yeah, this remains, this is just a constant look. It's also just comparing one letter. That's very easy. Good question. Okay, let's see if we can write it another way, shall we? So we'll go with isPalindrome. We'll say 3, takes in a string. All right, so what's another way? I'm just gonna move this.
There's another way to do it with pop.
What's another? So yeah, the string pop is a way, but if we, okay, and we could do that, but I kind of want to do something that, yeah, okay, sure, let's do it. Walk me through it, Siham. Let's do it.
Okay. So first, like I split. So let's array equal to string that split.
Right.
And then I do the 4-let character of the array.
Okay.
And I see if the character is not equal to the array dot pop, you return false.
Okay.
And then otherwise you return true.
In the for loop?
This is your return false.
Like
No,
this?
no. You just go after 2 square bracket, you put a return false in the
All
line.
right.
And then you check.
Return true.
Oh, sorry.
That's return true.
No problem. Okay. So let's see if this code still works. Okay, so we'll run it. And we are getting, interesting. I'm a little confused why this still works. Because,
I tried that and it didn't work for me.
well, it
Because when
should
you-
always return true, right?
Because when you pop in from the last element. And when you check in the first one. So
I
put
see.
in the middle.
Interesting.
I don't know if another case maybe may not work.
No, I see what you're saying. I think so this is really interesting. I've never seen this one. It's kind of cool. What's our time complexity here?
Linear.
Yeah, so it's still n. Still n, but we are doing a loop here, right? As well as the loop here. So it's kind of, it's 2n, although that does become n,
And
but it's not, it's definitely already slower than this one. Our space complexity is what?
Would it be, this is maybe taking a stab at it. Would it be like 1n because we're creating a variable like on line 416?
Yep, right. So our space complexity is n because we have to create this array. So although the solution works, I will kind of say I would be hesitant with this solution because usually you don't want to mutate the array as you're iterating through it unless, well, I mean, it depends, right? But like sometimes you will, unless it's like it's sorting it in some way. So that's more common, but this solution does work. Just be aware that this can be considered a little bit risky, but it works. So that's cool. I like it. That's another solution. Very cool. But definitely slower. So because of that, I'm gonna move that to here because this is cool because it's kind of right in between, which is tight. So I know the numbers are wrong, but okay, I'll fix them. That's all. I'll just fix them. Very cool. Okay, let's see if we can do another one. Const is palindrome. 4 takes in a string. Okay, anybody else have a approach that's like particularly different than these?
And I don't have an approach, but like, so like in order to, it seems like the fastest approaches are like the ones with like one iteration or something. So I think someone just mentioned, they just mentioned wild loop. Is there a way we can do like it with that? Or
A what one?
I think Deja just said wild loop. That seems kind of
Yeah, Deja. Deja said a while loop. Very cool. Deja, did you get it?
Yeah,
You want to help me walk through it?
sure. I'm sorry. It took me a while to get it.
Awesome.
I kept on remembering, like, forgetting little things of it. Okay, so it takes in a string. So let I start at 0. Then I have 2,
Okay.
the I and the J. And then let
And-
J, I'm sorry, I was playing around with it. Let J equal to the string dot length -1.
Okay.
Okay, so while I is going to be less than J.
Okay.
So if the string is at I,
Yep.
and it's going to check against the string at J. So
Right.
equal,
Okay.
And then you're going to increment I and decrement J.
Okay. What should we be checking for? If string at I is not equal to string at J, what do we want to be doing?
If it's not checking for it, if it's not, this is what I was messing up. It should be true, no, false, right? So.
Okay. Sounds good.
Yeah, I messed that up like 3 times. And then
That's
else
okay.
return true.
Okay. Very cool. Let's see if this works. Let's go through these. So, okay, well, so we'll say 4 here. Okay, this also works. Very cool.
I have a question, Corby.
Yeah.
Usually in interviews, because this is something that you picked up early, you asked about earlier about spaces. Like I kind of cheated, and I'm wondering if I can ask the interviewer if can I get a list of characters that, because you don't want spaces or numbers and stuff like that. So how would you approach asking somebody that?
Oh, you would just
Okay.
ask. You would say, let's read these questions. You would just say, like, are we concerned about string casing? Will there be any punctuation or spaces in the input? You just ask that right off the bat. It shows that you're thinking about edge cases and trying to plan. Because maybe they don't want. Maybe they have spaces, but they don't want you to they want you to ignore spaces, even though there are spaces. So then you have to think like, all right, so if that character is a space, I should just ignore that. Like it might work, now it works a little different, or you go ahead and remove all the spaces ahead of time to set it up.
Corey, you mentioned you would ignore the space. What do you mean by ignoring the space if it's like a character in the string?
Well, I might do something like if
Trim?
string at I is equal to a space, then I'm just gonna I increment and continue.
Oh, okay, gotcha.
Because now I don't do any of the rest of the stuff, and J doesn't get moved either. Something like that would ignore space.
Corey, if we split, can we just remove the space like by trimming function? Trim?
Yeah. Trimming removes I believe that moves the front if there's a spaces in the front or the back, but I don't believe that one removes spaces that are inside of the string. But you could split on a space and then join with no space, right? You could say like string dot split dot join. That's one way. I think there's a regex way, which you would say like string dot replace, and it's like something like with that. I think it's something like that. We could look it up. Here.
Corey, question.
Yes. What's the question?
My bad. Is it okay to use regex in an interview? Like, is that frowned upon? What's the situation on that?
Yeah. No. You should be using any tools that you have at your disposal. This is an okay way to remove it. So I was close, but not quite. It's backslash string. Or like that. So I was close, but not quite. Okay, so this is a really cool solution. This is going to work. Let's talk about what's the time complexity of this.
Linear.
This is linear, yeah.
Yeah, this is a linear. Specifically, this is like also like a half an n, which still becomes n, right? Because we're not actually iterating through the whole string. What's our space complexity?
Is it constant?
Yep, right. This is
Constant.
also constant. Constant at let's say O of 1, right? And that's constant because no matter what the size of the string is, we only are creating these extra I and J always. So very cool, Deja. Let's see if we can do maybe one more. So const is, you'll never forget how to solve a palindrome problem again. I was asked this once in an interview after the interview. It was a really weird interview. They gave me this long like online test, like which was really weird, just like in a room by myself. And then the team talked to me. There's 3 of them for like 2 minutes, or maybe it was 15 minutes, right? And then at the very end, they were like, also like, can you just write down how you would solve a reverse the string? I'm like, okay. Yeah, it was reverse a string. That's right. It wasn't palindrome, but it's the same kind of idea. I just reversed it in place. Anyway, I didn't get that job, but I saw them later, and I said like, hey, did you find the person? And the person was like scratching their neck. They were really nervous. It was weird. I'm glad I didn't get hired there. Okay. I forget their name. I can't name them. Sorry. Oh, thanks. Okay. But if you all get hired there, and I remember the name when you tell me that you're, I'll be very excited for it. Don't worry. That was also like, the test was insane, but I actually did really well, I thought, but I don't know. I guess they were looking for a different fit. So anyway, anyone think of another possible way that we could do this, even if you didn't solve it yet?
Recursively.
Recursive.
Yeah, right. Brutus dropped that earlier. Henry, Doug, nice. Right. So how can we solve this recursively? Well, maybe we do something like I, right? We can kind of do the same kind of logic that we've done earlier, which we could say like we could default I equal to 0 if I is greater than or equal to half our string, right? What would we return at that point if this was a base case?
Return true.
Okay, because we've made it through the array, right? Otherwise, we can say if our string at I does not equal our string at string.length, minus 1 minus I. We can just go ahead and return false, right? This is the same logic as our for loop here. Otherwise, we're just going to return isPalindrome 5. We'll pass in our string, and we'll increment our I by 1. And we'll test our work. So this will also work. So, right, let's just, I know this one's a little bit different, right? But it's really the same logic with say while or for, right? But we're just flipping it so that the recursive call is the loop, doing the loop for us, right? So that's what's important. We say like, we've got our base case. So this is when before our for loop terminated, right? We wanted our loop, well, we wrote a bunch of these already. We wanted our loop to terminate when it was, so while it was less than this size, we wanted the loop to run. So for us, we want it to stop running if it's already greater than or equal to. So in that case, we know we've made it all the way through the string, or like we've compared all the characters that are of relevance, and we'll return our true. Otherwise, we're doing the exact same logic from inside the for loop, where we're just taking the current I, which is the start of the string, and taking the length minus the 1 because of the way indexes are 1 behind, and then minus whatever I, checking. If those aren't the same, we can go ahead and return false. Otherwise, we know it's safe to go for another call where we'll just increment our I by 1, moving closer towards this base case.
Question.
Yes.
So would there be like a call stack ever if the strings get larger, or if the problem gets larger?
Oh, great question, Henry. I'm going to write that one down because it's such a good question, right? So the question is, will there be a call stack error if the string gets a lot longer? Who can answer that for us?
I say yeah.
I don't think so.
Henry says, yeah. Doug says, I don't think so. Let's take a vote. Let's do it. In the nonverbal feedback feature, give me a yes or a no if we will get a call stack error if the string was really long.
Okay, maybe by adding the map.floor, maybe by just going to half of the length of the string, maybe, but I still think you will get it.
Put your voice, get your voice heard. Make your vote. Let's practice our voting. We got 5 votes, 6 votes, 7 votes. That's that like Dracula. 1, 2, 7. Where's 8? 7, can I get 8? Oh, come on. We got to at least get half of the people participating. Okay, we got 9 votes. We're at half. It's half counting me. Some people are flipping, thinking it makes it look like it's more voting. 10. Where's these other 7 people? We can actually see the 7 people. Nover, Rafid, Ujwaka Pasi, put in your vote. Maria. Oh no, Maria voted. Kevin Wong. Brandon Brown. Yeah, there we go. Yeah. Okay. I just gotta start reading people out. I like this, the non-anonymous vote. Okay. For those of you who aren't voting, I'm very sad, but I'm gonna continue anyway. So everybody says no, except for Henry, the guy who asked the question. So drum roll, please, right? Yes. Yes, of course. Of course there'll be a call stack error because we can only have around 9,000 stack frames. So just like this is a call stack error. If I said const countdown, and that takes in a number, right? Let's just write like a little example here. It's going to console log log r number. And then I'll say if number is less than or equal to 0, just return. Otherwise, let's call countdown of num -1, right? This is essentially doing the same kind of thing. It's going to keep calling itself. But if we call countdown and we pass in maybe 11,000. Okay, 11,000 worked. Let's try more. Maybe we've got more stack frames now. There we go. Maximum call size exceeded. So this was 110,000. But if this was a while loop, it would have been no big deal, right? If I would have just written this like while num is less than or equal, whoops, to 0, console log, and subtract. Right, so if I did this, right, which is the same function, we'll see. Why did that not work? That's weird. Anybody know what's going on there? This is the same while number.
Do you have to console log it?
No, because I should be console logging my num here. Well, that's kind of, does it work with any number? It might be like so big it's just not printed? No. Wait. Okay, let me just like j equals num. I'm just gonna do it like with a different variable. See if that makes any difference. Oh, never mind. I'm being silly. It's this was the base case. This should be while j is greater than 0. Sorry about that. Being silly, right? So this console log's fine. Now if I did 110,000, right? It's going to, it's going to take a little while, but it works. But it's, I mean, it's slow, but it's as fast as you could go, right? So that's one of the powers between the iteration versus the recursive. So although recursion can look real sexy and sweet, like, and it is, recursion is tight. And for some problems, it's way easier to solve them recursively, and that can be better. But if you're actually writing something for a large scale application, like let's say you wanted to create a sort or something for, and you were trying to create your own programming language, you would want to write everything iteratively instead of recursively, because you wouldn't want to come into those types of problems. So that's a great question. I'm just going to move this down to the bottom because it's not really part of the lecture. So if our string was like 200,000 characters long, which is, don't get me wrong, that's like crazy long, and it's probably unreasonable for like the basics of this question, but it's feasible, right? And we would get a call stack error if that was the case. Any questions on that? So time complexity of this.
Would it still be
Recursion.
because you're incrementing your I and still going through the string?
Yep, you said still be n, right?
Yeah.
Yeah, so right, this is still like we're only going through half the calls still, which is still just n. How about space?
Constant. You're not creating any new variables.
Okay, so space, you should be aware of this as well. So, because that's a good instinct, Marvin. But those, like the reason that we get, like, why do we get a call stack error? What does that mean?
Oh yeah, because yeah, so we are actually accumulating data with each like recursion, right? Where
Right. So every time we create a call stack, we actually are using a frame's worth of memory. So it's not necessarily perfectly proportionate. Like, so you could say like program is still constant, but recursive stack frames
okay.
is more along kind of like n, right? Or
Yeah.
well, because you still have to create a frame for each call,
Yeah.
which is still going to be held in memory.
Yeah, that makes sense.
Would it be n or half of n?
Well,
Because
I
you're
guess it
only
would.
going until like,
Yeah, so it would technically be half of n, but that is n, right? But that's a good to be specific. But this is the answer you really want to tell people. But while you're like calculating things, it's fine to write like this type of thing just to demonstrate that you really know. But you wouldn't say like, oh, this is half of linear. You would still say like, this is linear. As this number approaches to infinity, it doesn't matter. Constants no longer will matter. Just because that's like, I think that's like the law of large numbers or something. I might have that wrong, but as it approaches infinity, it will matter less and less because the numbers just get so big. Okay, unless anybody else has another way to do it, I think we've exhausted the isPalindrome. All right, cool. Any
You could
questions?
do it for each, but nah, forget it.
Well, why? Can anybody say why that might not be a good idea? The for each.
You have to convert that string to an array first, because for each is an array method.
Okay, for each
and
is an
also
array.
for each is yeah, we use for each for side effects, and for each return value is undefined. So you'd have to like do more things after that. I'm trying to find a better way to like describe it, but it would
Yes.
be a messy sort of way to go.
Right. So if we were doing for each, although it's feasible, right? I mean, I'll just kind of write it. It won't take long. isPal for each, right? We have our string, which we have to make an array. So we would be like, we'd have to be splitting, and then we would have to do that for each, and we'll have our element and our I, right? But like, we would still have to iterate all the way through it because we can't stop the for each. And we also can't return out of the for each. So it become a lot like our first solution here, but a little bit more confusing, right? Because we would be like, let output equal true, and then it would be like, if element does not equal string at string.length -1 minus I, then output equals false, right? And then we would be returning output here. Like this, I think works. We can run it if people really want. But so it still works, but it's not a great solution because we're still iterating through the entire string instead of half the length of the string. And even if we found right away that the string isn't a palindrome, we're still iterating through the whole string, which is a waste of time, and we're doing the extra space. So I'm going to comment that method out just because I don't want people to study it. But it is feasible. That's true. Any questions on any of the methods that we went over today? especially from the recursion one, the while one, and the for loop one, because those are the best three.
Can you just explain the space complexity for the function is palindrome 5?
Sure. So similar to the way this worked with the for loop originally, right? Because it's all the same type of logic. Like the program itself doesn't ask for any extra space depending on the input. So it's like the program itself is running like in constant because it's not, it just has its I, right? However, with every recursive call, you are creating a stack frame, right? Remember, like when programs run, they run from this call stack. So it gets, this thing has to get evaluated before this thing. So it keeps adding every time there's a recursive call until we finally get, oh, my hands you can't see, until we finally get the solution. And then they just start popping off the stack until it finally gives us back that final return here, right? So it kind of keeps building up, the stack bubbling up. And that's the exact reason why if our string was like 1 million characters long, our program would run out of memory. So it would run out of money. It would run out of memory, and it would say like, hey, like, why are you making so many calls? And so that's because each one of those frames, those recursive calls, is taking up some memory. It's so this isn't technically constant. It's constant if you're not worried about stack frames. So like if your interviewer asked you, you would say, well, without the stack frames, it's constant. But with the stack frames, you know, we're creating another frame for every single call, for every single character, or half the characters of string. Does that help, Ashia?
Yeah.
Cool. Any other questions? Okay, cool. So I'm going to stop my share, stop recording. Rachel,